allotropic form of phosphorus. We already learned about the group 15 elements. Which are the group 15 element? Nitrogen, phosphorus, arsenic, antimony and bismuth. Am I right? These are the group 15 elements. Already we learned about that nitrogen and their compounds, preparation, ammonia, preparation, structure, everything. Right? The next element, it's the second element, is about the phosphorus. Here, what is about the allotropy? Allotropy means one of the element having same physical state, but it have more than one different structure, different form. More than one form, that we are saying allotropy. Okay. Allotropy means same. Am I right? Allotropy means element having different forms, same physical state, and it contains more than one form. That we are saying allotropy. Okay. Here phosphorus, we are saying about the phosphorus, it have several allotropic forms. For example, now I am saying about that one. Number one is about the white phosphorus. Number 2, red phosphorus. Number 3, black phosphorus. These are some of the most common forms of phosphorus. And also, in addition, 2 more allotropies. That is about that scarlet phosphorus. Scarlet, S-C-A-R-L-E-T, scarlet phosphorus. And also, violet phosphorus. Okay, scarlet, we are saying about that blood color, and that is the color about the scarlet. Next, about the violet phosphorus. These are the allotropic form of phosphorus. Here, one of the very important about that, when the white phosphorus on heating, if you, suppose I am taking one of the white phosphorus, this white phosphorus on heating at 420 degrees Celsius, this white phosphorus is converted into red phosphorus. Am I right? Here, white phosphorus on heating at 420 degrees Celsius, it is converted into red phosphorus. And also, red phosphorus on boiling. Okay, boiling means we are taking some inert atmosphere, okay, and condensed. Okay, that is about the boiling. The boiling, red phosphorus on boiling, it is converted into white phosphorus. Okay. About the white phosphorus, don't forget that white phosphorus on heating at 420 degrees Celsius, we get red phosphorus. And also, red phosphorus on boiling, we get white phosphorus. This is a concept. And one more about that. What is about the black phosphorus? The black phosphorus is divided into 2 types. One is about that alpha black phosphorus and also beta black phosphorus. Okay. Which are the 2 types? Alpha black phosphorus and also beta black phosphorus. Here, white phosphorus on heating at 803 Kelvin, we get alpha black phosphorus. Okay. Red phosphorus on heating at 803 Kelvin, we get alpha black phosphorus. And also, white phosphorus on heating at a higher temperature, that is about that 473 Kelvin, we get beta black phosphorus. Okay, these are the types, variety types. Just we can be discussed one by one. Okay. Here, the white phosphorus is become a colorless. It becomes a pale yellow. Pale means light color. Okay, light yellow. White phosphorus is a colorless, and it becomes a pale yellow due to the formation of a layer of red phosphorus upon standing. This is also known as yellow phosphorus. Can you understand, dear children? Here, the white phosphorus is also known as yellow phosphorus. It is a poisonous in nature, poisonous, very poison, and also it has a garlic smell, a characteristic garlic smell. All of you know about the garlic, am I right? It glow a dark due to oxidation, which is called as an Phosphorescence. Phosphorescence. Once again, listen all of you. White phosphorus is colorless. Okay. White phosphorus is colorless. It is one of the freshly prepared white phosphorus. One of the newly prepared or freshly prepared white phosphorus is colorless. It becomes pale yellow due to the formation of layer of red phosphorus upon standing. Okay, it is also known as yellow phosphorus. It is highly poisonous and also it has a characteristic garlic smell. It glow in the dark due to oxidation. In dark area, it glow due to the oxidation, which is known as phosphorescence. Okay, and also one of the important one-word question. Its ignition temperature is very low. Okay, its ignition temperature is very low. It undergoes a spontaneous combustion. It undergoes one of the spontaneous combustion in air at room temperature. It gives phosphorus pentoxide. Phosphorus pentoxide. Penta means 5. Phosphorus 5 oxide. Okay, that is the formula is P2O5. Okay. Next about, we can learn about the white phosphorus. Here the white phosphorus can be changed into red phosphorus. The white phosphorus can be converted into red phosphorus by heating. What's the temperature here? About 420 degrees Celsius in the absence of air and light. Okay. I told that here the white phosphorus is a colorless and becomes a pale yellow. Am I right? And also it is almost this phosphorus is also known as an yellow phosphorus. It's a poisonous in nature. Am I right? Have a garlic smell. Here we are learning about the white phosphorus. Here the white phosphorus can be changed into red phosphorus by heating. That is, a white phosphorus is converted into red phosphorus by heating at 420 degrees Celsius. Am I right? In the absence of air and sunlight. Here, it is red phosphorus is not poisonous. Okay, red phosphorus is not poisonous. It does not show phosphorescence. It also does not ignite at low temperature. Okay. Here the red phosphorus can be converted into white phosphorus by boiling. Already I told you that. Okay, this is the red phosphorus. It is converted into white phosphorus by boiling in an inert atmosphere and condenses the vapor underwater. This is about the white phosphorus and about the red phosphorus. Okay, the phosphorus has a layer structure and also acts as a semiconductor. Let us see when we draw the structure of white phosphorus. Okay, structure of white phosphorus. Here, this is one of a phosphorus. This is another phosphorus. This is another phosphorus. And we are joined like that. Okay. Phosphorus. Here, phosphorus having the 4 atoms. Am I right? The 4 atoms. Here having 4 atoms. The 4 atoms of phosphorus have polymeric structure. Which is structure? Polymeric structure. With a chain of P4. How much phosphorus having? 4 phosphorus atom. Am I right? So it is P4 linked tetrahedrally. Okay. Already we learned about that. Nitrogen, what is the bond? A triple bond. Nitrogen, triple bond is less stable than phosphorus single bond. Phosphorus atoms are linked through a single bond. Okay, rather than triple bond. Already nitrogen, we know about already the nitrogen family. Nitrogen have a triple bond, but phosphorus has what bond? A single bond. Okay, here we learn about another 2 types of phosphorus. Which are the another 2 allotropes of phosphorus? Scarlet phosphorus and also violet phosphorus. Okay, this is about the phosphorus. Next we can draw the structure of red phosphorus. Okay, same like that. Red phosphorus. phosphorus, 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 phosphorus. We can be joined as a tetrahedrally, am I right? Next, again joining phosphorus, 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 phosphorus. Join. Again joining one more P4 atom. Phosphorus, 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 phosphorus. Okay. This is about the red phosphorus. Okay. Next, about what are the properties of phosphorus? Phosphorus is a highly reactive element. Okay. It is a highly reactive element. First, we can be reactive with the oxygen. Reaction with oxygen. Here, yellow phosphorus readily catches fire in air, giving a dense white fumes of phosphorus pentoxide. Red phosphorus is also reacts with oxygen. Red phosphorus is react with the oxygen, we get phosphorus trioxide, and also we get phosphorus pentoxide. The two important products it will be given. Am I right? We are learning about the chemical properties. The phosphorus, it is a polyatomic element. Previous I told you that phosphorus is a polyatomic element. I mean, here P4 phosphorus on reacts with oxygen. We are writing O2. On heating we get P4O6. Otherwise, we can be written as P2O3. The same formula is correct. P4O6, phosphorus trioxide. Okay, otherwise we can write P2O3. Here we are making here 2. Means it is balanced. We can be written as P2O3. 2P2O3, like that. We can write that we are counting. We have the correct formula. Okay. Anyhow, P4O6, phosphorus trioxide. And one more, we can be balance the equation. How much oxygen is there in the reactant side? Having only one molecule, that is a 2 oxygen. The product side here having 6 oxygen. So make it 3 here. 3 into 2 is equal to 6. Equation is balanced. Next about, this is about the phosphorus trioxide. Next about the phosphorus pentoxide. Phosphorus reacts with oxygen. We get phosphorus pentoxide. The formula is P4O10. P4O10. Otherwise, we can be written as P2O5. Okay, P2O5. If you are making 2 means, that is correct. Okay, P4O10. So, phosphorus P4, okay, balance. What about the oxygen? If you are making 5 here means, the reactant side 5 here means 5O2. Now it is balanced. Next. Phosphorus reacts with the chlorine. We get phosphorus trichloride. Phosphorus reacts with the chlorine. We get phosphorus trichloride, and also phosphorus reacts with the chlorine, we get phosphorus pentachloride. Okay. Here, phosphorus reacts with the chlorine, we get the tri and pentachloride. What about the yellow phosphorus? The yellow phosphorus reacts violently at room temperature. The red phosphorus is heating on, while the red phosphorus reacts on only heating. Okay. Here I have one of the difference. What is the difference means? What about the yellow phosphorus? What about the red phosphorus? Yellow phosphorus while on reacts at room temperature violently. Am I right? Room temperature. But in the case of red phosphorus, it reacts while only on heating. Can you understand? Yellow phosphorus reacts at room temperature. Red phosphorus react only on heating. There is a small difference. Anyhow, phosphorus reacts with chlorine. We get phosphorus trichloride. Phosphorus reacts with the chlorine, one more compound, we get phosphorus pentachloride. So we have to write the equation. P4, that's a phosphorus on react with the chlorine, Cl2 gives PCl3, right? Next, how can you balance the equation? Here having 4 phosphorus, so make it 4 here. Now how much chlorine is there? 4 3s are 12, am I right? So make it 6 here. Now the equation is balanced. What about the next one equation? P4 plus Cl2 gives PCl5, that is a phosphorus pentachloride, PCl5. How much phosphorus is there? 4 phosphorus. It is a polyvalent element, am I right? So make it 4 here. 4 into 5 is equal to 20, am I right? 20 chlorine is there, so make it 10 chlorine atom, 10 chlorine molecule, now it becomes 20. So, first equation, we learn about that phosphorus trichloride. Second equation, we learn about the phosphorus pentachloride. Next, one of the very important question. How is phosphine prepared? Other one question. How is sodium hypophosphite prepared? Okay. The first question. There's a 3 possible of question. One is about that. How is phosphine prepared? Another one. How is sodium hypophosphite prepared? Another one question. What happens? Phosphorus reacts with alkali solution. What happens? Phosphorus react with alkali solution. These are the 3 possible questions here. Anyhow, we can be discussed. Okay. Phosphorus reacts with alkali. Yellow phosphorus, we are taking yellow phosphorus, reacts with alkali and boiling at an inert atmosphere, we get one of the product called phosphine, P-H-O-S-P-H-I-N-E, phosphine, okay? It's one of the gas, okay? Don't forget that, one of the gas. Here, phosphorus acts as one of the reducing agent. Phosphorus, in this equation, phosphorus acts as one of the reducing agent. Don't forget that. Okay. Anyhow, we have to write the equation. Phosphorus P4 and reacts with alkali means we are taking sodium hydroxide, NaOH alkali solution. Okay, NaOH alkali plus water molecules. We get first product we can be written as sodium Na, sodium H2, hypophosphite PO2. What is the formula here? NaH2PO2. Am I right? NaH2PO2. And also we get a liberating phosphine. What is the formula? pH3. This is one of the gas, am I right? Phosphine. Okay, one of the very important product, phosphine. Okay. Here, how can you balance the equation? Here, how much phosphorus is there in the reactant side? P4, am I right? So, in the product side, there have only two phosphorus. If you are making here 3 means 3 NaH2PO2. Making 3 means, here 3 having, this side also 1. So, 3 plus 1, 4 phosphorus. So, now it is, phosphorus is balanced. What about the sodium? here 4 sodium is there, sorry 3 sodium is there, so make it 3 here. Now we can count the hydrogen. 3 in the reactant side, product side, 3 into 2 is equal to 6, 6 plus 3 is equal to 9. So here the reactant side we make it 3 here, so 3 also. Next here also, if you are making 3 water molecules, no, it is balanced. 6 plus 3, 9. Now the equation is balanced. Okay, very, very important question. Try to learn this question. Okay, next. What happens? Phosphorus reacts with nitric acid, that is a concentrated nitric acid. Concentrated nitric acid. Okay, what happens? It reacts with the concentrated nitric acid. Phosphorus, that is P4, react with nitric acid, HNO3. We get orthophosphoric acid, and also nitrogen dioxide, and also we get water molecules. Okay, here we are using one of the catalyst is called as an iodine. Iodine crystal is used as the catalyst. We have to write the equation P4 plus HNO3, concentrated nitric acid, HNO3 gives H3PO4, that is about the orthophosphoric acid, otherwise we can say phosphoric acid. Orthophosphoric acid is otherwise phosphoric acid, that is H3PO4 plus NO2, nitrogen dioxide plus water molecules. How can you balance the equation? How much phosphorus is there? The reactant side 4, so make it the product side also 4. And here also having water molecules. So the water molecules here make it 4. So 4 into 3 is equal to 12 plus 8 is equal to 20 hydrogen having. So the reactants will also make it 20. So hydrogen balanced, the phosphorus balanced, and about the, what about the nitrogen? Here 20, so make it, react products will also make it 20. Now the equation is balanced. Next, what happens? Phosphorus reacts with a metal. Here we are taking a few metals like calcium, magnesium, and also sodium. Here, phosphorus reacts with magnesium, we get magnesium phosphide. What is the formula of magnesium phosphide? Mg3P2. Mg3P2. Am I right? This is the formula of magnesium phosphide. We can write the equation P4 plus Mg gives Mg3P2. Mg3P2. Magnesium phosphide. We can balance the equation. How much phosphorus is there? The reactant side 4. So make it here 2 means 2 into 2 is equal to 4. Okay. Because already here having phosphide P2. Am I right? So 2 into 2 is equal to 4. So how much magnesium is there? 2 into 3 is equal to 6. So make it 6 magnesium. Next one, calcium. Phosphorus reacts with the calcium. We get calcium phosphide. What's the formula of calcium here? Calcium phosphide. Ca3P2. Ca3P2. So 3 calcium is there. So we can balance the equation. Reactant side 4 phosphorus, so make it 2 here. 2 into 2 is equal to 4. So how much calcium is there? 2 into 3 is equal to 6. So 6 calcium. Now the equation is balanced. Next one. Phosphorus reacts with sodium. We get the sodium phosphide. Sodium phosphide formula Na3P. Na3P. Don't forget that Na3P. Sodium phosphide. So how much phosphorus is there? 4 phosphorus. So make it 4 phosphorus here. So how much sodium is there? 4 into 3 is equal to 12. So make it 12 sodium. Okay, these are the equation. Next we can learn about the use of phosphorus. We know that one. Our matchbox, am I right? Matchbox having the red phosphorus. Red phosphorus is used in the matchbox. And also, it is used for the production of certain alloys such as phosphor bronze. These are about the uses. Next. One of the very important question, phosphine. Okay, phosphine. One of the very important question. Phosphine. What is the formula of phosphine? pH3. Here, phosphine is one of the poisonous gas. Rotten fish smell. What is the smell means? Don't forget, it's a one-word question. Very, very important one-word question. Phosphine has rotten fish smell. How can you prepare the phosphorus? Already we learned the equation about the phosphorus. Phosphine preparation. That's the previous equation we learned that one. Phosphorus reacts with alkali. Am I right? Phosphorus reacts with alkali. That we learned. Am I right? So, here once again we are learning preparation of phosphine. That is phosphorus reacts with sodium hydroxide solution, alkali solution. Here we are taking white phosphorus. White phosphorus reacts with the sodium hydroxide solution in an inert atmosphere of carbon dioxide or hydrogen. So, we get sodium hypophosphate and also we get phosphine. Okay, sodium hypophosphate, that is NaH2PO2 plus phosphine. So, we can write the equation P4, that is about the phosphorus, reacts with NaOH plus H2O gives, we get three important products. One is about the phosphine, that is a pH3, phosphine, because we are writing the phosphine preparation. So phosphine, we have to write phosphine gas. Next, sodium hypophosphate formula NaH2PO2. NaH2PO2. How can you balance the equation? Reactant side phosphorus P4, the product side here 2, so make it 3 NaH2PO2. Now the phosphorus is balanced. What about the sodium? Reactant side make it 3. Now sodium is balanced. Now the product side we can count the hydrogen. 3 into 2 is equal to 6. 6 plus 3 is equal to 9. So if you are making 3 water molecules means 3 2 are 6. 6 plus 3 had 9. Now it is balanced. Phosphine is one of the dihydride, that is P2H4. Here, it is by passing through a freezing mixture. Phosphine, one of the dihydride, that is P2H2, is passed through a freezing mixture. The dihydrate contains the white phosphorus does not. Now we learn about the preparation of phosphine. That is about, we are learning about the lab preparation. Next, 4 other method, how we can be prepared phosphine. 4 other method. Okay. First one, calcium phosphide. Calcium phosphide undergoes hydrolysis with the water. We get phosphine. And also we get calcium hydroxide. We can write the equation. What is the formula of calcium phosphide? Calcium phosphide means Ca3P2. Okay. The one of the calcium phosphide is used for a home signal. I will explain later. Okay, uses we can be discussed. Calcium phosphide formula is Ca3P2. On reacts with or hydrolysis with water. Water can be written as H2O. We get phosphine. What is the formula? pH3 gas. And also calcium combines with the OH to form calcium hydroxide. How we can be balance the equation? How much phosphorus is there? 2 phosphorus. So make it the product side 2 phosphorus. So we get 2 phosphine. How much calcium is there? 3 calcium. So make it the product side 3 calcium. So count the hydrogen. Phosphine having 6 hydrogen. And here also having 6 hydrogen. So total we have 12 hydrogen. So make it water molecule 6. Equation is balanced. Next about the aluminum phosphine. Aluminum phosphine on reacts with the hydrochloric acid. we get phosphine gas and also aluminum chloride. We can write the equation. Aluminum phosphine ALP plus hydrochloric acid HCl gives phosphine PH3 gas plus aluminum combines with the chlorine to form aluminum chloride AlCl3. How can you balance the equation? Phosphine having 3 hydrogen, so make it 3 hydrochloric acid. So aluminum balanced, and chlorine is also balanced. Next, one of the very important question: how is phosphine prepared from phosphorus acid? How is phosphine prepared from phosphorus acid? Otherwise, what happens? Phosphorus acid on heating. What happens? Phosphorus acid on heating. We know the phosphorus acid formula. What is the formula? H3PO3. What is the formula for phosphoric acid? H3PO4. Don't forget that. Okay. Phosphorus acid, H3PO3. Phosphoric acid, H3PO4. So, phosphorus acid on heating, it becomes phosphoric acid. What is the other name of phosphoric acid? Phosphoric acid. So, phosphorus acid on heating, H3PO3 on heating, we get phosphoric acid, H3PO4. And also we get phosphine, PH3. So, how can you balance the equation? Here having the product side 4 phosphorus, reactant side, if you make it 3 H3PO4 means phosphorus is balanced. Okay. Negative 4, now the equation is balanced. Okay. Next about a pure sample of phosphine we can be prepared by taking one of an substance about the phosphonium iodide. All of you know the formula for ammonium iodide. What is the formula for ammonium iodide? Ammonium means NH4. Am I right? NH4, ammonium iodide, NH4i. Like that, phosphonium iodide means PH4i. Am I right? PH4i, phosphonium iodide, on reacts with caustic soda solution. Caustic soda means we know that sodium hydroxide. Sodium hydroxide is one of the caustic soda. So, we are adding sodium hydroxide, NaOH, we get. This sodium combines with iodine, we get sodium iodide. And also, here, one of the hydrogen from H4, one of the hydrogen reacts with the OH to form water molecules. The remaining is PH3. We get phosphine. Now the equation is balanced. Next about what are the physical properties? Physical properties, don't forget that physical properties. Phosphine, about the physical properties, it is a poisonous gas with the rotten fish smell. It is a colorless gas. Am I right? Don't forget that it is slightly soluble. It is slightly soluble in water. It is show a neutral to litmus paper test. Already we learned litmus paper about the 10th grade. Then it condenses to a colorless liquid at 188 Kelvin. And about the freezing to a solid is about that 139.5 Kelvin. There are some physical properties. Don't forget that phosphine, a rotten smell, rotten fish smell. Okay. Poisonous gas is about the one-word question. Next about the chemical reactions of phosphine. Phosphine, this is on heating at 373 Kelvin. 317 Kelvin. Phosphine on heating at 317 Kelvin. We get red phosphorus and also hydrogen. Red phosphorus. So we can write the equation PH3 gives 317 Kelvin on heating. P4 plus H2. So 4 phosphorus in the product side. So make it 4 the reactant side. Now hydrogen is about 4 3s are 12. So make it 6 into H, 6H2. Am I right? Equation is balanced. Next about the combustion. Combustion means burning with oxygen. Okay, burning with oxygen, heating with oxygen. That is about we are saying combustion. Am I right? Phosphine is heated with oxygen. We get phosphorus pentoxide, and also it on heating with water molecules. Phosphorus pentoxide on heating with the water molecules, we get metaphosphoric acid. Important point. First, phosphine on react with the oxygen, we get phosphorus pentoxide. Penta means 5, all of you know that one. Okay, that is we can written as P4O10, already we learned. And also we get water molecules. Next, this phosphorus pentoxide again reacts with the water molecules, we get metaphosphoric acid. What is the formula for metaphosphoric acid? HPO3. HPO3. And also we get water molecules. Okay. So, we can be write the equation. pH3 plus O2 gives P4O10 plus water molecules. So the product said how much phosphorus is there? 4. So make it react Z 4 phosphine. Next we can be count the hydrogen. Here hydrogen 4 3s are 12. So the product said make it 6 water molecules. 6 into 2 is equal to 12. Next we can be count the hydrogen oxygen. Here having 10. 10 plus 6 18. Am I right? Sorry. 10 plus 6 16. Am I right? So if you are making 8 means 8 into 2 is equal to 16. Now the first equation is balanced. Second equation, the same product we are taking. The product, which are the product here? P4O10 and also 6 water molecules. Am I right? So make it here. Right here, P4O10 plus the same water molecules. I am writing here 6 water molecules we get. What is the product? Metaphosphoric acid. Meta, that is HPO3. Metaphosphoric acid. H3PO3. So how much phosphorus is there? 4. So make it 4 here. Then water molecules. Already they are having 6 water molecules. So 6 2s are 12. Out of 12, 4 is over. What is the remaining? 8. Then we can make it 4 here. So 4 2s are 8. Now the equation is balanced. Next about that, basic nature of phosphine. And one of the important one-word question. Phosphine is a weakly basic. Okay, please underline that one. Phosphine is a weakly basic. It forms a phosphonium salt. Phosphonium iodide. Phosphonium salt. Okay. What is about the formula phosphonium salt? Now only we learn pH4i. pH4i. Phosphonium iodide. So we can write the equation. pH3 plus hydrogen iodide gives pH4i. Because this hydrogen is attaching here. So pH4i. The phosphonium iodide again react with the water on heating. So we get again phosphine. What is the formula phosphine? pH3. Phosphine pH3 plus we get hydrogen combines with one of the hydrogen, we get H3O plus, and also iodine is also iodine is also leaving. Okay. So equation is balanced. Phosphine on reacts with chlorine. Phosphine. What is the formula phosphine? pH3 on reacts with the chlorine Cl2, we get phosphorus pentachloride, that is PCl5 plus hydrogen combines with the chlorine to form HCl. So how can we balance the equation? Phosphorus is balanced and the same having. What about the chlorine? Here having 5, here having 1. So before that, you count the hydrogen in phosphine. How much is hydrogen having? 3 hydrogen. So make it the product said 3 HCl. So 3 plus 5 Cl means 8. So make it 4 in the reactant side, 4 Cl2. Now the equation is balanced. One of the important question. Reducing property of reducing property of phosphine. That is silver nitrate. I am taking one of the silver nitrate salt, one of the silver nitrate, which reacts with the phosphine. It reduces into silver phosphide. Silver phosphide. What is the formula? Ag3P. Okay, how to write the equation? Phosphine, that is pH3 phosphine, reacts with one of the salt, silver salt, AgNO3, gives this Ag combines with the phosphorus, we get Ag3P, silver phosphide, and also hydrogen combines with NO3 to form HNO3, nitric acid. So how much is silver is there in the product side? 3 silver. So reactant side make it 3 AgNO3. So how much in nitrate is there? 3. So the product side make it 3 HNO3. Okay. Now the equation is balanced. And also one of the important point, boron trichloride. This boron trichloride with the phosphine, it form a coordination compound. Coordination compound. One of the boron trichloride and reacts with the phosphine, it gets a coordination compounds. What is about that one? We are writing the equation. I am taking boron trichloride BCl3. Boron trichloride. Already we learned boron trichloride formula BCl3 and react with the phosphine PH3. We get one of the compound called, first you have to write Cl3b. That is about that boron trichloride. Cl3b, boron trichloride. And one space there, make it pH3 phosphine. Here phosphine can donate a pair of electron to the boron because it is a Lewis acid, am I right? Here, what is the atomic number of phosphorus is 15, am I right? 15 is the atomic number of phosphorus. First shell we can be accommodate 2 electrons, second shell 8 electron, third shell remaining 5 electron, am I right? So 5 electron. Here out of this 5 electrons, that's a valence electron. This is 5 electron is bonded to 3. Out of this 5, 3 electrons are bonded to each hydrogen atom. That is pH3. Am I right? P, H. Here having 2 electrons. That is, we can be say lone pair of electron. This lone pair of electron donate to BCl3. BCl3 means boron trichloride. Boron, what is the formula? What is the atomic number of boron? Boron is equal to 5. First shell we can be accommodate 2 electrons. Second shell we can be accommodate 3 electrons. So boron also bonded with 3 chlorine atom. That is B, Cl, Cl, Cl. So there is no electron for bonding with boron trichloride and also phosphine. Am I right? Boron also no electron for bond with the phosphine. Am I right? So here phosphine, that is phosphorus having 1 lone pair of electron. So this lone pair of electron of phosphorus can be utilized for bonding with boron trichloride. So we are giving one of an arrow mark. So here phosphorus donate a pair of electron to boron trichloride and make it on bond. That bond we are saying coordinated coordinate bond. Otherwise we can be say the entire complex. We are getting one of the total complex, that is Cl3b. Phosphine having 2 electron gives donate a pair of electron and make it one square complex. That compounds we are saying coordination compounds. Okay, that we have one more lesson. That time we can be discussed. Next about the structure of phosphine. What is about the structure of phosphine? You have to draw the structure. Phosphorus is surrounded by 3 hydrogen atom. Now only I told about that phosphorus atomic number 15. It have 1 lone pair of electron, am I right? So phosphorus 2 electrons, lone pair of electron, hydrogen. Here about the bond angle, don't forget about the bond angle. Bond angle, one hydrogen and other hydrogen, the bond angle is about the 93.5 degree. And about the bond length, about that 1.42 Armstrong. Okay, don't forget that. Make it that one. Here, phosphine is a sp3 hybridized. Am I right? sp3 hybridized. Already I told that one. How will you find the sp3 hybridized? First, you count how much a bond pair is there. Phosphorus, hydrogen, phosphorus, hydrogen, phosphorus, hydrogen. So 3 bond pair. Have here one lone pair of electrons. So 3 plus 1, 4. 4 becomes 1. 2 becomes sp. 3 becomes sp2. 4 becomes sp3. 5 becomes sp3d. Am I right? This previously we discussed in the 11th grade. Okay. So here sp3 hybridization. These 3 orbitals are occupied by bond pair. The 4th corner is occupied by lone pair of electrons. This is about the lone pair of electrons. Here the bond angle is reduced to 93.5 degree. Okay, don't forget that about the hydrogen. This is reduced to 93.5. So phosphine has a pyramidal shape. Which shape? Pyramidal shape. Okay. Next, we can be discuss about the uses of phosphine. In our chemistry, phosphine, that is a burning gas of phosphine, serves a signal to the approaching ship. Okay, this is one of the very important. Burning gas of phosphine serves a signal to the approaching ship. And also one more point, it is used to producing smoke screen. It is gives large smoke. The very important, very application we can be discussed. In a ship, we are taking one of the wooden container, or we can be say a perside container, and a small make it on hole like that, and we are taking a mixture of calcium carbide and calcium phosphide. These two salt we are taking here. A mixture of calcium carbide and also we are taking calcium phosphide and thrown into the sea. Okay, that is the sea water we are thrown into the sea. What happens? Here the two important gases are producing. One is about that phosphine gas. What is the formula of phosphine? pH3. Phosphine, and also we get acetylene gas. Acetylene means all of you know C2H2. Am I right? C2H2, acetylene. This gas, these two gases are producing. Here what is happening here means, here this acetylene gas is ignites with the air and catches fire, and also phosphine also catch the fire. Due to this fire, it make a huge flame, one of the huge flame. I'm right. There is a one like a large smoke. It gives a large smoke like that. Due to this burning of gas, it serves as a signal to the approaching ship. Okay, signal to the approaching ship. This we are saying that home signal. One of the very, very important question, home signal. Okay, this is about the use of phosphine. Okay, so this area today we discussed that one. Please all of you take down the assignment. Which are the assignment I am giving? First one, uses of phosphine. Number 1, use of phosphine. Second one, preparation of phosphine. Preparation of phosphine. Third one, allotropic form of phosphorus. Allotropic form of phosphorus. Okay. Thank you all of you. Thank you. Have a nice day.